Now let's have a look at the merits of the median. The first merit that we talk about is that it is not unduly affected by extreme values. This is especially because the median is just a positional average. So if you remember the earlier example where I had given you the income of 5 families, since this is the income of 5 families expressed in ascending order, so we know that your median term will be the middle term, which is 5 plus 1 by 2, which is the third term, right? So we know that the median here is 2600. Now if instead of 2400 I wrote any other value less than 2600, that is, if I wrote something like this, and if I replace 2750 by something like 10,500, even in these cases the median remains the same, because in this case the ascending order or the order of items have not been changed. So the middle term or the middle value which divides the entire distribution into 2 equal sets remain the same. So this is an example which can tell you that extreme values will not affect the value of the median, because it's only a positional average. On the other hand, for the same data, had we been calculating the arithmetic mean, you would see a very big change in the value of the arithmetic mean if I change these two values to 1200 and 10,500. Now, another merit of the median is, like I said earlier, simple to calculate, easy to understand. It can be calculated even for open-ended data, because essentially we are only interested in the median, the middle value or the median class. So even if you have open-ended data, you can calculate the median for that. Another advantage that median has over the arithmetic mean especially is that it can be graphically determined. This was one of the demerits that had been mentioned about the arithmetic mean, that you cannot graphically determine it. And another big advantage is that it can be used and calculated for qualitative data as well. So it is not limited to just quantitative data, it can be used for qualitative data as well. Looking at the demerits of the median, first is that it is not rigidly defined. This is evident from the fact that the procedure differs if you have odd number of values, observations, and even number of observations. If it's a continuous series, even if it's an even number of observations, we don't do n plus 1 by 2, we just need to do n by 2, and so on. So it is not rigidly defined. Taking the average of the two middlemost observations in some cases and not taking an average in some cases, these things create a lot of confusion, right? Another thing is that it is not based on the magnitude of all items, right? So as I showed you earlier, if I change 2 of the values on either side of the median to very large or small numbers, it does not affect the median at all. So drastic changes are not reflected or captured by the median value. It cannot be, or it does not lend itself to algebraic manipulation. For instance, if I have the median of two different sets of observations regarding the same variable, I will not be able to tell you what would be the median of the combined group. It can be difficult to calculate, especially when you have numbers of large magnitude and a large number of observations as well, since arranging them in order will be tough. Compared to the arithmetic mean, the sampling stability is not there in the case of the median. If you compare sampling stability of arithmetic mean and median, the sampling stability of arithmetic mean is much higher. So all the samples from the same population will give much closer arithmetic mean values, but that is not so in the case of median. And finally, practically, it is the